purpose of this lesson is a quick review of unit circle trigonometry ideas. And the main idea for us is to be able to find, say, sine of 3 pi on 4, okay, without using our calculator, just using exact values. Okay, I guess first should probably just remind you about the difference between degrees and radians. So this would be 0 degrees, this angle on the x-axis. This way are positive angles. So this would be 90 degrees, 180, 270, and 360. Okay, so the basic conversion we use is that pi radians equals 180 degrees. So you should be able to remember most of these like that. So if I'm after like 30 degrees, I'll think, okay, that's 180 divided by 6. So it'll be pi on 6 radians. Okay, if I'm after 60 degrees, okay, it's 180 divided by 3, so pi on 3 radians. Okay, you should be familiar with this from last year. Okay, the other key enduring understanding that you should have from last year, okay, is that when we draw this angle, whatever the angle is, okay, the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. And we exploit this idea of the unit circle to get an understanding of these values. Okay. In a few special cases, okay, we'll use this unit circle diagram. So if I want, for example, sine of pi on 2, okay, I'll remember that the sine of the angle is the y-coordinate. So I'll go up to where pi on 2 radian is, and 1 is the y-coordinate, so sine of pi on 2 will be 1. So for any of these angles, like for example cosine of minus pi on 2, we're just reading off these graphs. Minus pi on 2 means go in this direction. Okay, pi on 2 radians, so we get to minus 3 pi on 2. So I could say, yeah, if I wanted to, it's the same as cosine of 3 pi on 2, and cosine is the x-coordinate, so it'd be 0. Okay, just those basic examples where we're reading off the values. Okay, so we've got some other relationships as well. So tan of the angle is the sine divided by the cosine. Okay, or alternatively, you can think of it as the y-coordinate divided by the x-coordinate. Okay, and we've also got this Pythagorean identity, okay, basically exploiting the fact that in the unit circle we have sine theta here and cos theta here. Okay, if I call this side A, B, and C, using Pythagoras, I'll have cos squared theta plus sine squared theta equals 1 squared. And I can use that relationship to simplify some ratios. Okay, but we won't be using that very much this year, just a reminder. And when we're trying to find, these are exact value triangles, should be a title there. Okay, when we're finding sine or cosine of an angle that's not a multiple of pi on 2 radians, okay, we'll use these exact value triangles. If you want to remember it in degrees and convert it, that's fine. Okay, otherwise you can just remember it with the radians there already. 30 degrees is pi on 6. Well done. Okay, 60 pi on 3. Okay, you don't need to remember this part of it. Okay, just those two right angle triangles. So if I'm doing a problem and it asks me for cosine of pi on 3, okay, I don't just go to my calculator. I'll draw this right angle triangle. I'll remember that cosine is adjacent over hypotenuse. So from the point of view of pi on 3, adjacent is 1, hypotenuse is 2. Okay, and I'll be able to do that in the same way over here. For example, tan of pi on 4, okay, is opposite over adjacent, so opposite over adjacent is 1. Okay, so you need to know these two these two exact value triangles. So look at an example of what we actually set out to do. A few steps that you can use to guide your solution. If you're okay with it already, just go ahead. Okay, so we're trying to find the exact value of these two ratios. I'll do part B first, just because it's the positive case. Okay, so part B, step 1, draw a circle with the x and y axes. Okay, and we can draw a little circle around it. Label the quadrants anti-clockwise from quadrant 1. Okay, all stations to central, or whatever you want to use. Use the positive x-axis as 0. Here's my positive x-axis, 0, and draw the angle in the correct quadrant. So this 5 pi on 4, I know is going to be 5 on 4, lots of 180 degrees. So sometimes it helps to type 5 on 4 on your calculator, and I'll say 1.25. Okay, so this angle is really 1.25 pi. I know that 1 pi is 180 degrees, so it's going to be out here somewhere. Okay, 5 pi on 4. Okay, so I've done that in the correct quadrant. Determine the size of the angle, size of the angle between the angle and the nearest x-axis. So I need to find what's that little bold angle in there. Okay, I know this angle all the way is 5 pi on 4. I know this is pi radians here. I need to find the difference between 5 pi on 4 minus pi. Okay, if you struggle, you can use the calculator, but we should be okay with changing pi to 4 pi on 4 and then doing the subtraction over this on the top. Pi on 4. So this little angle in here is pi on 4. I should have drawn my diagram bigger. Pi on 4 radians. Okay, so I've done that as well. Determine whether the value will be positive or negative. So the quadrant that this angle is in is the quadrant where only tan is positive. Remember, these letters mean all of them are positive, only sine, only tan, or only cos are positive. So this cosine 5 pi on 4, I know it'll be a negative value. Okay, so I've done that. And I'm trying to find cosine of pi on 4. Okay, so determine the sine, okay, plus or minus, and then we'll find just the ratio of that small angle between the line and the x-axis. Always needs to be the x-axis. Okay, you might think from here, use the calculator. No, you draw the exact value triangle that has pi on 4 in it. 1 root 2. Cosine is adjacent over hypotenuse, so from this pi on 4, I've got adjacent over hypotenuse minus 1 on root 2. Okay, if you want to be fancy, you can write it as minus root 2 on 2, but I'm happy with either one. Okay, sometimes people just like that the denominator shouldn't be a surd. Okay, they want rational, like whole number denominators. All right, so maybe have a go at part A by yourself, and then I'll do the solution. So press pause, do it yourself. Pause. All right, just follow the same process. Draw the axes. A, S, T, C. Use the positive x-axis as 0. Draw the angle in the correct quadrant. So my angle is negative. Okay, so I'm finding sine minus pi on 4. So I'll draw my 0 here. Minus 4 pi on 3, correction. Minus 4 on 3 is like minus 1.33. So it's the same sort of scenario where we're going in the negative direction. Okay, and we're going to go just a little bit past minus pi. So in the negative direction, that's minus pi on 2, minus pi. over here somewhere will be minus 4 pi on 3. Too much going on there. Minus 4 pi on 3. In the sine quadrant. Okay, so I've done most of these steps. Drawn the angle, determine the size of this angle. So what's the size of this little angle in here? It's going to be pi on 3. Okay, just the size of it. We're in a quadrant where sine is positive. Okay, so this is going to be the same as positive sine of pi on 3. And then I'll just access my exact value triangle. Okay, so the big angle, the small angle, 2, 1, root 3. Okay, sine of pi on 3 is opposite over hypotenuse. And that's the sort of working out that we'd expect. Some sort of diagram drawn, the exact value triangle drawn, and some sort of process down here. Maybe you're taught something slightly different, as long as you can see some clear process going on. If you don't have that process, you're going to be in trouble when it comes to solving trig equations, because you'll have no idea what's going on. So there's a whole heap of these that you can practice in the textbook, finding exact values. Maybe look at your notes from last year. Okay, these two are more sort of like problem solving ones. Alright, so if sine of pi equals 12 on 13, and the angles between pi on 2 and pi, find cos and also tan. So if I draw a diagram of what this looks like, know that the angles between pi on 2 and pi, okay, we're out here somewhere. It says that sine is 12 on 13. So for this angle, whatever this angle is, okay, we know we've got opposite of 12 and hypotenuse of 13. Okay, in that little triangle that's formed out there. Okay, ASTC. So if I'm trying to find cosine theta, looking at this diagram, the angle is going to be the same angle, and I just need to find whatever the cosine value is of this small angle here. Okay, so where we'll go about this, I know cosine is adjacent over hypotenuse. I need to find this adjacent side. Okay, you can use Pythagoras to get 5. Okay, so the value of cosine will be minus 5 on 13. Okay, that same triangle, that same little angle in a quadrant where sine is negative. Okay, hence find tan. Okay, we know that tan theta is sine theta on cos theta. So sine was 12 on 13, cos is 5 on 13. Okay, divide these, correction, cos is negative 5 on 13. Divide these, I'll get minus 12 on 5 as my tan value. Okay, you could have solved this a few different ways. Okay, you could even try and find what the angle is first. Okay, find what this little angle theta is, and find cos theta. Okay, but it's probably easier this way, just using that right angle triangle. Okay, so for the final example, this is a pretty classic sort of problem. Probably saw a few of these last year. Yeah, we don't know what this angle is, but we know what the sine and the cosine of it is. So again, we'll do part B first, because I think it's probably easier. I'm trying to find cosine of 4 pi plus x. So draw my diagram. Where's this angle? 4 pi. I know that means that you go around 2 pi, and then go around again to get to 4 pi. Okay, and then an additional x radians. Okay, remember we can just keep going around the circle periodically. Okay, we'll write on this diagram our ASTC idea. So cos of 4 pi plus x will be, it's in a quadrant where all of them are positive, the same as positive cosine of this small angle, which is x. Okay, so we'll end up with positive 0.8. Okay, you don't need to write positive if you don't want. Okay, and part A, sine of 3 pi minus x. Okay, I'll do the same thing. There's 0. So I'm going around 3 pi radians, so I go around to 2 pi, and then I need to go another pi. So this is pi or 3 pi, depending how many times we've gone around the circle. From 3 pi, I'm going to go back x radians. So this angle here is 3 pi minus x. Put my cast diagram in. Okay, this means I'm in a quadrant where sine is positive again. Looking for positive sine of x. Okay, so I'll get positive 0.6 because I know that sine of that angle is 0.6. Okay, this is all mainly a review, so it's just stepping you through it. You need to have a go at all these sorts of problems.